I'm not sure that I'm an expert on AI. I don't think anyone is, and I'm not sure any of us can really be precise about what we mean by AI. But there's a general fear at the moment. Will AI replace various people in jobs? So since this is a tech conference, can AI replace programmers? Short answer, yes. So, if you're hungover and need to go and drink some water, okay, you stayed, yes, but, and I think most of this morning we're going to be looking at some of the buts. Before we get there, I think we need to have a little bit of a think about what AI actually means. The word's got a very long history. It means different things to different people. If you go back before we start talking about AI, there's elements of paranoia and various fictional stories. You might recognise Dr. Frankenstein's monster in there. And to some extent, that story was asking about what happens if we create an artificial life, which is part of what AI might be about. Is that a scary, horrifying thing? How will it interact with humans? I'm sure many of us know the story of Frankenstein and his monster. And that niggles in the background when people talk about AI or any kinds of machines or strange technology doing stuff. Some forms of AI do move into having a body. Maybe it's a robot that interacts with the world in some way, shape or form. That gets referred to as hard AI. There's another element of this, another way of looking at things, sometimes what's called soft AI, where we're just talking about software. So maybe that's some kind of neural networks going on. Maybe it's just some clustering algorithms. Sometimes it's being used for some kinds of surveillance. All the CCTV cameras around there are using types of facial recognition. Some of them are. There's elements of paranoia possibly in the background and strange dystopian sci-fi ideas. Some elements of AI are more about games. I know there's some people in the audience who work at games companies, and you do get the computers to build bots that interact with people, and that's cool and fun and not necessarily dystopian and scary. And lots of things about AI that have hit the news have been around playing chess and more recently playing Go. And I think that's a cool thing, computers learning how to play games with us, because that's fun. So maybe it's scary, maybe it's fun, maybe it's about games, maybe it's about more worrying things, maybe it involves robots, maybe it just involves software. Yeah, very hard to define AI. Have some more water. The word's quite an old word. Some of you've probably heard of John McCarthy, invented Lisp. We'll come back to that in a bit. He was viewing it as, can we reproduce human intelligence electronically? Whatever that means. Is intelligence all about electrical signals moving around your brain? This asks questions about if you can build a brain, will it just start thinking for itself? But then we need to define what thinking means, which is really difficult too. And if everything's just electrical signals, how do you know what's real? And, well, just leave the Matrix quote for you. What is real? How do you define what is real? Real is just electrical signals interpreted by your brain. If we don't perceive something, is it not real? Does it not exist? We could get very philosophical very quickly. John McCarthy, now we talked about the air conditioning just now, and this is for real. He said, machines as simple as thermostats could be said to have beliefs, and having beliefs seems to be a characteristic of most machines capable of problem-solving performance. Do you think the air conditioning is some kind of AI? I suspect most of you go, no, it just changes the temperature in the room, sucks all the water out of your body and makes you get a headache and feel very tired. So drink some water, people. When they first came about, they were sometimes called the governor, and the idea that the machine would spot what was going on around it and change the temperature for you was regarded as some kind of worrying new tech. Should we trust the thermostats or the air conditioning to control things for us? Has it got some kind of intelligence? It's slightly odd and quirky looking back to someone saying it's got a belief there, because I guess we programmed the belief it's got as to what the optimal temperature is. Is that a belief? Not sure. Has anyone come across the so-called Chinese room argument? Okay, there's one or two. If you program a computer, give it a set of instructions, and then it does things like changes the ambient temperature, or drives your car for you, or chooses what you're going to watch on Netflix or some other streaming service, does it know what it's doing? Is it thinking? Does it have beliefs? Has it got intelligence? Or suppose you put someone in a room who doesn't speak Chinese and gave them a set of instructions, and they got past something in writing in Chinese, and they had to answer the question in Chinese, and they just followed an algorithm and managed to correctly answer the questions. If you were outside the room and you spoke Chinese, passing the questions in, and were getting coherent answers back out again, would you think the person inside the room could actually speak Chinese? The argument there is, just because something's following an algorithm or instructions doesn't mean it's actually speaking Chinese or thinking or has any kind of intelligence. And yet, to an extent, when I do wonder, are we actually just following some kind of hardware instructions? Is our brain just hardware that somehow, don't know about programmed, because that implies the idea of some intelligence that's programmed us in the first place, but are we somehow just following some kind of algorithm without realising it? Is that thinking? I don't know. Big questions. I think this keynote's going to be more throwing out questions and give you something to think about. Apologies if you wanted an expert to tell you what everything meant, because the thing about experts is they didn't end up with more questions than answers, I think. The AI encompasses loads of different things. Like I said, it might be robots, it might be AI bots in a game, it might be something that can play chess, it might be something that's controlling a building for you. There are other elements of AI. For a while, people were talking loads about machine learning. I've noticed recently people have stopped referring to machine learning so much and started saying AI again. The words tumble and move round. But I thought I'd talk about what machine learning used to mean. Was people are describing machine learning nowadays as, well, basically analysing data, or what I think of as statistical analysis. So machine learning, the machine learns from data, is something you'll hear people say loads. So just throwing in some little bits of history so you can be informed and say, no, actually, that's not right. This dates back to the 1950s as well. Someone called Arthur Samuel coined the term and described it as a field of study that gives computers the ability to learn without being explicitly programmed. Now, what does that mean? We talked about the Chinese room and having like a recipe, a set of instructions to follow blindly. And then you've explicitly stated what to do under each circumstance. So how does a computer learn to do something? Well, he set things up to try and get a computer to learn to play drafts. And at that point, you can't, if you explicitly program things, you could have a lookup table, brute force, like work out every possible move and what the optimal one is to win. If you involve an element of randomness, like maybe I'll put the piece here, or maybe I'll put it here, maybe I'll go left, or maybe I'll tend to go right. If you bake in a small element of randomness to your algorithms, then that allows more possible things to happen. So you haven't explicitly programmed things. You need a way of seeing how well you're doing. So you need some kind of scoring function, some kind of feedback. As soon as you've got feedback in there, and probably an element of randomness, you've got the essence of almost every machine learning algorithm going, and many AI algorithms. Why was he doing this? Well, he felt that teaching computers to play games would be really fruitful, developing tactics to solve general problems. If a computer could figure out how to win at drafts, then it could use the same strategy of doing something a bit random and having some kind of feedback function and be able to solve other problems as well. And you do see machine learning solving a variety of different problems, and sometimes making things worse, say. But it's always got that feedback element and something random happening. Now, we've talked about learning and beliefs and big philosophical things. I'll give you my perspective and you might not agree with me. I think a lot of things being described as AI at the moment actually are not some kind of Frankenstein monster we've created with an independent existence of its own and its own set of beliefs going around interacting with the world. I think what we've got when we talk about AI is something on a spectrum between augmentation and automation. So I don't think we've actually got AI at the moment. And I don't know whether we ever will have. So that's a question I'm going to throw out to you and we can all chat about it over a coffee. I kind of hope we do, because I love my sci-fi books and films and I love dreaming about what it would actually be like. But I think where we are now is on that spectrum between augmentation and automation. Computers helping people or computers replacing people. The history of machines and tech is frequently about automating things, whether it's in farming and having machines to drill and then sow seeds. And as you move through time, weaving has a connection with the beginning of computers. It's frequently about automating things, maybe making things faster, saving loads of manual effort, being able to produce more food or more materials. Maybe doing things smarter, so maybe using less resources as we do it. But something faster or smarter or anything automatic isn't intelligence, is it? I don't think it is. Don't know what you think. But a lot of things we describe as AI are like the thermostat or the air conditioning or your car driving itself. Or something automated. Not sure whether that counts as intelligent. Just leave that as a question for you. Should we automate everything? Loads and loads of words on the slide, and I'm shoveling more and more and more things in. So many things we've tried automating, and it doesn't always work out well. Does anyone remember the chatbot Tay from a while ago? It got turned off. It was released onto Twitter and behaved actually to some extent the way you might expect a younger child to behave, started behaving the same way as the people it was interacting with, and it said some really quite offensive things, as some kids do. But with kids, you have a chat with them and talk about whether that was nice or not. But maybe that AI chatbot didn't have a way of giving it feedback on whether it's being nice or not. How do you explain to a robot that it should be nice? Maybe you need to look at the rules of robotics from Asimov and read more sci-fi before you start doing this kind of thing. So Tay got turned off. I harbour a secret belief that if there'd been a way of having more feedback in that loop, it might have panned out better. You see some other things going on. I've seen some systems that work out sentence lengths for prisoners, and quite frankly, they're racist. They reflect what we're doing at the moment. We give them data, and it observes that black people get longer sentences than white people. So it does what we're doing at the moment. So if you let the machine learn from the data, it might point out to you that you're not very nice. Perhaps AI is feedback for us, Oh, perhaps we're an experiment in some sci-fi story. Who knows? Yes. Should you automate something? Well, maybe, maybe not. I have some strange things going on, like trying to look at pictures of people's faces and work out whether they were potentially criminals or not. I don't know if anyone recognises the phrenology head at the bottom. There was a patch during like 100 or so years ago where people were thinking if you could tell from the shape of people's heads whether they were likely to be criminals or not. That's nonsense, right? Only people have recently been doing some machine learning to try and redo this. It's still nonsense. Don't automate that. It's pointless, it's stupid and possibly dangerous. Crazy. Now, if you start looking at some of the natural language processing or the image recognition systems, all kinds of trouble ends up happening there. Already mentioned some racism going on. Some of the computer systems that start analysing our words will tend to say, if they see a doctor, that's likely to be a father. If they see a nurse, that's likely to be a mother. That's giving us feedback as well about the kind of language we use. Now, whether you want to let the system take over and control more than just the air conditioning for you based on the weight of data we've got at the moment or not is a question. I suspect we need to be a bit more careful. Now, so that's automating things, augmenting things. There's that other end of the spectrum. So, you've got more than just a computer. You've got keyboards and a mouse and sometimes like pens. Reading far too much history as I was preparing for this, I was thinking about CAD systems, and they're far older than I realised. And having extra peripherals gave people ways of designing things. So augmenting the setup they got, and the computers were then helping people do things they couldn't do themselves. Help make our life easier, giving us more possibilities. That's quite exciting. And, well, that goes on a trajectory as well. Anyone recognise the guy in the middle? The Register took up calling him Dr. Cyborg for a while. I think he's a professor at Warwick. He experimented with having implants to. Basically, he kept forgetting his door pass when he went to work. So he thought, if I put the RFID tag in my arm, then I can just. I've always got it with me, so I can always get through the door at work. And everyone went, that's probably not a very sensible idea, but him being an academic researcher, he thought he'd try it anyway, and it worked. And that's left us onto a trajectory where you get your cat's microchips so you can find them afterwards. So he's experimented with some things that's brought about some beneficial stuff. Now, if you go on a trajectory and end up augmenting yourself completely, you might end up near Robocop or something, and I'll leave that to you to decide if that's a good idea or not. Oops, too fast. There's other kinds of augmentation as well. Music. If you've got a classical guitar, that can make one lot of notes. If you step it up to an electric guitar, and we had McCarthy talking about electricity earlier on, that gives you new possibilities, you can make different sounds. If you look at effects pedals as well, there's some really interesting physics stuff going on in there. And obviously there's some of C++ people getting into the audio stuff. Listen to Timur talking yesterday. You can do more things. So this gives us there's some potentially frightening things, and there's some really exciting things in here as well. Or you could describe languages, programming languages. We don't build hardware. Well, maybe some of us do. Few of us program in machine code. Maybe you do some assembler every now and again. Maybe you do some C. Maybe you do some C++. You've got levels of augmentation there. Now, that's ways of talking to the machine. But the higher level language is helping us out and letting us do more things. I've talked about that automation to augmentation thing. There's some good in there and some bad in there. Still don't think it's intelligence. We talked about the air conditioning taking over and drying us out. I've talked about automating almost everything. Automating things is good. Automatic doors can be good. Having a continuous integration set up that automatically builds your code for you and runs your tests for you. Don't know whether that's AI, but it's some kind of automation. That's a good thing. Anyone got some automated deployment scripts? Some nods? See, that's a good thing. That's much better than doing it manually, surely. Everything, though? Taps? I have problems with automatic taps. I get 50-50 chance of it actually producing any water when I need it. Automatic flushing toilets, that's another strange thing, in my opinion. Self-driving cars? Is that a good thing? Is it a bad thing? It's a thing. I've got mixed feelings about that one. I can see why some people like the idea. I think it's something someone's thought of and thought we could do this, and we could. Like I said, just because you can doesn't mean you should. Earlier sci-fi stories promised us flying cars, not self-driving cars. Go on that way. I personally, and I don't know about you, would much rather have a transporter. Now, I've seen my Star Trek, and I know that theoretically several things could go wrong there. But instead of sitting in a car and being driven for 4 hours, I'd much rather go like that and then turn up at my final destination. So this is a plea to anyone who's watching and working on self-driving cars. Please make transporters work. And whilst you're doing that, if you can make replicators work, and certainly 3D printers are a step that way, that will be tremendous as well. Whether it's AI or not, I don't know, but that's really cool automation of stuff. Now, there's a thing. What's the carbon footprint of a self-driving car? I know some people have tried to get the train here from miles away to bring down the carbon footprint. And I think a lot of AI is using so much electricity. People are tending to talk about deep learning, which means a deep neural network. Now, I'm not explaining what a neural network is. Some of you know what it is. My executive summary of it is it involves sending some numbers in, doing some multiplying and adding up. And if you do deep learning, you then do some more multiplying and adding up, then some more. Then some more, so the deep just means lots and lots and lots and lots of sums over and over again. Some of these things take hours and hours and hours to train and use an awful lot of electricity. And what do you get out of the end? It goes, yay, I've seen a cat in your picture that you've just posted on Facebook or something like that. Useful? Fun? Yeah, okay, fun. Intelligent? Oh, if it's using up that much electricity, maybe not sensible. It is fun to play with, don't get me wrong, but I think sometimes tech gets a bit carried away and we do some things that are a bit pointless. And we are having an impact on the environment sometimes. Maybe we should be measuring the carbon footprint of our build system or our test running or the final product we're making. Just going to throw that one out there. And people describe automation as magic, but that's the simplest way to describe what things are. Perhaps I should have said a neural network's magic rather than multiplying and adding up. If you start looking around for wizards, when I first came across wizards, it was in Visual Studio. You click a button, it automatically generates some code for you, and it's usually a bit wrong, and it's horrific, and then kind of wanted to refactor it, and then went, oh, hang on, let's just leave the boilerplate to it. After you create a wizard, you typically want to add it to Visual Studio. Yeah, maybe you do, maybe you don't. I've noticed recently there are lots of AI platforms out there that promise that you can just, by a few clicks of buttons, wizards will automatically generate the models for you. And you need no machine learning skills. Is that a good thing? Have any of you got colleagues who use wizards to automatically generate some C++ for them and go, yes, I absolutely know what I'm doing? And you're going, hang on, can we just talk about what we're doing here? Are you scared of people out there who can spin up some cloud service, click some buttons and build a system? Stunned silence. I find it worrying that it says you don't need any skills in this. And I think all of us are capable of at least understanding the basics and building up some skills so we can have a sensible discussion about whether what we're doing is sensible or not. I've been quite negative about some of the things people are doing, but some of this stuff is really cool. I'm particularly excited about some of the music and the gameplay, because that seems harmless. Went that way. See one C++ person dressed as a wizard. Russell's not here. If anyone knows Russell Winder, he makes a splendid wizard. Just thought I'd throw that in. Automation's definitely useful. I've talked about your CI pipeline. I think there's a talk, it was probably yesterday, I missed it, about automatic refactoring of your code. If you've got some automatic formatting, then we don't need the long arguments about the brace placements. You can just change it to be the way you want it and then arm wrestle your colleagues. So yeah, actually, I said, can AI replace programmers? We are already using the computers to change and tinker with our code. All right, sometimes it's generating the code for us, like the wizards. But that's all right, or all libraries. Well, actually, hang it. You don't compile your code by hand, do you? You use a compiler. So you're already using computers to do elements of the programming for you. And you haven't been replaced at that point. So maybe we're going to be okay, maybe. Programmers rely on their computers to do a lot of work for them already. How am I doing? Okay. So perhaps we shouldn't be too afraid, just slightly afraid. We've talked about loads of kinds of automation. Some of the early things from the 60s were promising. Automatic nanny that would take your child out for a walk. Or we're talking about building brains. Is that AI? I don't think so. Got a robot vacuum cleaner at home, which is great, means I don't need to do the vacuuming. I think you could, if you look back, you'll see stuff from the 60s talking about, automatic maids for your house that would do the vacuuming for you, but they always envisaged them looking vaguely humanoid shape as a robot and then moving a vacuum round, rather than it being just dedicated machine to do the vacuuming. And yeah, our attempts at building brains have ended up being various kinds of neural networks and deep learning. And that's a very software thing, and it is just doing some multiplying and adding up, really. It helps you spot cats and fit data. And I think that's some kind of automation. So it's not AI per se. I mentioned some of the problems when we tried to build chatbots and when we've looked at natural language processing just now. A famous company recently decided that they were going to automate sifting through CVs. And the AI, well, basically, I don't know if you describe it as taking the piss or just gave us some feedback. It chucked out all the women's CVs in the end. Any hint of you being female, wasn't interested. It spotted, women. It managed to learn which were the women's colleges, so anyone who'd been to one of those, you're out. If it said something about women's chess club, you're out. What was it doing? Well, if you've got 95% of people in a company who are male, and your feedback function looks for accuracy, if you don't measure accuracy correctly, instead of learning properly, The simplest thing to do is go, right, well, I'm only going to hire men. Because then that matches your 95%, so that's bound to be a winner. That's quite worrying. But that doesn't mean that the AI is biased. It means what we're doing is suboptimal. There's a phrase. Yeah, you can look that up. I'm not naming and shaming the company, but it happened. They turned it off and went through the CVs by hand. Probably the right solution. Yeah. If you automate what we're doing now, then will anything ever change? If we automate some of what we do now, right, that's cool. We need to be intelligent about this and have this discussion and keep our eyes on what tech companies are up to, what the news is claiming, and let's have a discussion about this. Because AI is cool, because computers are cool, we can do some splendid things with computers and AI, but we're tending to do some daft things with it as well. What sort of horrible dystopian future will we end up in if we don't have these discussions? Do we want AI police? Maybe not. Maybe. Okay, so I did say I was going to talk about can AI replace programmers. So I've skirted around the issue of what AI means and just given you questions and things to think about. So I mentioned deep learning. There's not time to explain all of that. I can talk to some people afterwards and give you a bit of an overview if you don't know how that works. Would a neural network or AlphaGo or any of the things you've seen that have been claimed to be AI pass the Turing test? We're familiar with the Turing test idea? Yeah? So, right, I said earlier on, is the machine thinking or is it actually learning? And those were discussions that were happening in the 40s, 50s, 60s, as people were beginning to learn to build computers right from the beginning of our industry. And Alan Turing said, look, I can't describe what thinking means precisely and mathematically, so hang it, I'm not going to bother. If you've got a person and this AI behind a screen that just maybe type, so chat to an interrogator, can the interrogator spot which one's which? If they can't, then it looks like the machine's intelligent. And it was a way of going, look, we can't work out if something's thinking or not. You can't work out if I'm thinking at the moment. I'm not sure if I'm thinking. I think I've probably not had enough water and the AC is a bit warm. Are you thinking? Do you know what thinking means? No one knows. Maybe it is just electrical signals. The AI, particularly the deep learning networks, learn, if that's the right word, and again we can probably invoke the Turing test to avoid having to be precise here, very differently to us. If you've got kids, how many times do they need to see a picture of a cat or a dog to be able to generalise and go, cat, when they see a cat? Handful of times, like 10, 20, done. Do you know how much training data tends to be used to spot cats versus dogs? It's not like 10 or so. You're talking tens of thousands of images for the machine to learn, which harks back to me saying about how much electricity we're using. We could just employ 5-year-olds to spot cats and dogs, mechanical Turk style, and save the planet. Though then there'd be a question about slavery instead. Does AlphaGo enjoy playing Go? First time I came across a smart speaker, I asked if he was happy. And he said, I'm sorry, I do not understand the question. Subsequently, I noticed other people asking their smart speakers if they're happy, and they've started to respond by, yes, sure, I'm happy to serve. It's what I'm here for. So it's learnt to just say something back. If you've got an AI that created some artwork, would it be able to pick it out and say, I made that? See, maybe that's what AI is about. It's about a self-awareness thing. Again, if you watch kids learning, they'll start saying, I made that, and start developing a sense of self at some point. And I don't think our augmentation to automation spectrum's anywhere near that. All right, I'm circling in on whether AI is going to replace programmers or not. I really am honest. I've gone around the houses somewhat, but I mentioned that the machine learning phrase was invented around the idea of trying to get a computer to learn to win at drafts or checkers without being explicitly programmed. It just told whether it won or lost. And it kept retrying. So it had that feedback, a random element, and eventually it learnt to win. Then we step it up and we end up with computers playing chess. And that was happening in the 80s and 90s. And then they started to be able to beat human experts. Though some of them were doing a kind of brute force, maybe 5 moves ahead, which is more than a human can hold in their head. But computers have got more RAM and can do calculations quicker than we can, usually. So it could win that way. What was more difficult was the game of Go. Anyone play Go? I love Go. The rules are so simple. You just put a tile on a square, and you can't put it on a square if it immediately is surrounded. And your aim is to surround your opponent's pieces and capture as many of them as possible. That's it. Possibly wasn't the best explanation ever, but you can explain it in about 3 steps, unlike chess, which is far more complicated. But there's so many possible moves. Just like hundreds and hundreds of zeros afterwards. It's more than exponentially harder than chess. That the same strategy of just brute forcing slightly more than the human brain can manage was not going to work. And recently we have got computers that can play a good game of Go. What's happening there? Well, it learnt to play against itself. Started off completely randomly. I said right near the beginning, loads of AI involved some kind of feedback and something random. So it started just randomly putting tiles down and learnt what happened. And then it started to play against itself. And actually, that's how I learnt to play several games as a child, was sit down and when no one's looking, you try against yourself and then you go, oh no, hang on, now I can take that piece off. And you learn by, and that's called reinforcement learning. You play it just round and round. So lots of AI is about that iteration and some feedback. Does it enjoy playing Go? Does it know it's playing Go? Is it AI? People claim that this is. It's got elements of intelligence and learning, but I'm not sure the computer's actually learnt anything. But the fact it can play Go is actually really cool, really interesting. If you've not read about it or watched any of the games, go check it out. So, what is AI? Let's be a bit more explicit now. I think that a lot of the algorithms look like this. There's some kind of while loop, does something random to begin with. Neural network will come out with some numbers at random for the weights for all of the nodes, so the things we're going to multiply by. Try it out and go, nah, see, it was a dog, not a cat. That's wrong. Remember the things that were better, and then just nudge the numbers a bit, up a bit, down a bit, left a bit, right a bit. Try it again. Ah, still not a dog. Ah, all right, try again. This begs loads of questions. What does done mean? How good do you want it to be? Do you want it to be 95% accurate and then it'll throw out all the women's CVs? When you test it, what are you testing? If you're going to test your code, can you sit down in advance and write all the tests you need? And then you let the machine generate your code for you? Or maybe you want to be part of the feedback loop yourself to just nudge things if you haven't managed to think it through and come out with a necessary and sufficient set of tests. Can AI replace people? Well, I talked earlier about like farming and the textile industry. We do see a history of machines replacing people. I talked just now about maybe invoking a child to disambiguate cats and dogs in pictures, and then there's worrying things about child slave labour there. We use the word a Luddite for someone who breaks machines or who's not interested in tech. We need to remember that historically that was actually about workers' rights, but this could all get quite political at this point. I think some people are afraid of AI in one sense of the word Luddite. They don't understand it, so smash the machine. But in another sense, there is some slave labour going on. Anyone use the mechanical Turk? Oh, interesting. Anyone here realise you're being used as a free mechanical Turk? Ooh. So, lots of machine learning or AI systems at the moment need labelled data. When you've tagged your friends in pictures, you've labelled data. When an online translation service says, rate this translation or tell me what I could have done better, has anyone given feedback on that? Has anyone suggested a better translation? Bet you have. You've been used as free slave labour to label the data for the machines. Suckers. Mind you, that means I can then look up what German words mean and learn, so you've helped me. So, it's equivocal. You start noticing the number of times your smartphone asks you to rate things or label things or ask for feedback. You're being used to train the machines for free. Just keep your eyes open. So, okay, now that you've been told you're being used for slave labour, you should maybe be afraid, or maybe not, I don't know. Let's find out if we can make ourselves unemployed. How do you figure out if someone can program? If you're going to interview someone, maybe you'd like to see the code they can generate, or at least they can write some code that does the required task. And quite a frequent one we invoke is FizzBuzz. Have we come across FizzBuzz? Some of us have. So, numbers, maybe 1 up to 100. It's controversial, and whether you start on 0 or not, we can discuss this. Multiple of 3, say fizz. Multiple of 5, say buzz. Multiple of both, say FizzBuzz. Anything else, 1, just say 1. It's perfectly straightforward. Or is it? Can a machine generate the code to do this? Because if it can, it's just a small step from there to be able to write a trading system or control the air conditioning or drive a car. Well, it's a big step. So, I said at the beginning of the talk, can AI replace programmers? Yes, but here's the crux of the matter. I think there's more than one way to do this. But a simple thing to use is something called genetic programming. Now that's based on the idea that's behind genetic algorithms. An algorithm works on a list or array of numbers, Boolean strings, whatever. Genetic programming works on a tree structure instead. And as soon as you've got a tree structure, you can represent a program. And if we've got the right tests in place, then we could persuade the machine to generate code for FizzBuzz. Again, it follows the algorithm that I pulled out earlier. It does something random to begin with. Test things, rinse and repeat. I'll show you more specifically in a mo. If you want to know more, I've written a book. Again, mentioned I've written a book. It's got genetic algorithms and other things in. And involves lots of ways to code your way out of a paper bag, which I think is a far better proof you can program than just being able to do FizzBuzz. But that's another story. So if you want to know more details about genetic algorithms, actually, you could read my book or just look it up on the internet and try and code this up yourself. It's not as hard as you think. The idea behind genetic algorithms is borrowing from evolution. So hoping that something will start in one place and evolve and get better, like Darwin's evolution. I've pulled out a quote here from quite an old book. Evolution's driven by a feedback mechanism caused by the success or otherwise in surviving and reproducing, and modifications of behaviour over lifetime in response to experience. Well, actually, if we want to evolve as programmers and get to be better programmers, we need some kind of feedback and to evolve and respond to our experience. And talking of feedback, Jens has mentioned that we should give feedback on the session, so don't forget to do that. That quote's from a guy called Norbert Wiener, who wrote a book a long time, again in the possibly early 60s, called Cybernetics. And he theorised that all intelligent behaviour is the result of feedback mechanisms. Now, AI and machine learning does have the feedback mechanisms in. And I think, in my personal experience, I've become cleverer or learnt more when I've had helpful feedback from people. Feedback is a clincher in this. And that was an important early step towards the development of modern AI. Let's be specific about genetic algorithms then. So, remember, genetic algorithm does an array. Genetic programming does a tree structure. So, genetic algorithms first. Generate some random arrays. You want booleans? Put some random noughts and ones in. You have a whole gang of these called a population. How many? Yeah, see, you need to decide that. Or you can go meta and use some more machine learning to try and work out how many to do. But then you need to figure out how to set that one up. So you could do some more machine learning to figure that out. But then you'll need to... So somewhere down the line there ends up being a human making a decision. Do something random, and then we have our for loop or while loop. We test the arrays and see if they do what we want. Whether it's escape from a paper bag or something more useful than that, doesn't matter. Choose some of the better ones and maybe take a chunk of one and a chunk of another and make a new one. Like the idea of how you use DNA strands in reproduction. And then maybe if you've got booleans, you flip a bit once in a while. This is giving you an exploration of all of the possible numbers. You're not checking everything out. If you had time to check all the possible combinations, you might as well do that and brute force it. If you've got a big problem, this will explore some things. And because you've got the tests in there, which, by the way, you've written, the machine can't decide them itself. So you've got to tell the machine what the tests are. It'll then work out some combinations of things that do well enough, or at least report the better ones for you. And you've defined better. So, if you've got 5 noughts or ones, you can see in the picture, maybe if you started with all of them on or all of them off, take part of each one. That's called crossover. Where you put the split point, that's another decision you've got to make. See, the machine's not making many of the decisions itself. We've got to decide so much for it. And then maybe flip a bit. And you'll end up with some different arrays, and some of them might be better. Like I said, that's genetic algorithms. The only difference for the genetic programming is a tree structure instead of an array. Someone called Koza invented this. So if you want to read more, check out some of his books, or at least read executive summaries of them, because they are big and fascinating. And you can use this for more than generating programming language, programming expressions. You've got a spatial element going on, so you can design circuit boards with it. You can do all kinds of things. But we're figuring out if we're going to make ourselves unemployed or not, so let's keep this focused. Very like the genetic algorithm we saw just now, we just replaced the word array with the word tree. So we do something random, test them, pull out the better ones, mutate some bits, see what happens. Can you write tests up front for FizzBuzz without writing FizzBuzz yourself? I thought I could. And then I decided, actually, I'd probably miss some cases, so I cheated and I borrowed 8 test cases from Kevlin Henney. Certainly every result's a fizz, a buzz, a FizzBuzz, or a number. Now whether that's some kind of, you use that as a string or not, is by the by. Every number corresponds to its ordinal position. So 1 is the first one, 2, second one, 4, fourth one. Every third one is a fizz, every 5th one is a buzz, and so on. So we've got 8 tests. So now in that loop we had just now, deliberately go back, while we test these, I can give the random trees a score out of 8. And if anything gets 8, yes, we've made ourselves unemployed. But we had to turn to Kevlin Henney to get the tests in the first place. And if you're going to get a computer, well, one of your employees is going to replace you with genetic programming, make sure they specify all the tests up front in advance and they're convinced they cover exactly their requirements. That's kind of like test-driven, but if you told people they had to do all of it and they had to be necessary and sufficient tests, they'd probably forget some cases. Maybe the test-driven means some human in the loop giving some feedback and going, oh yeah, actually I meant this, I didn't mean that. So, but the tests are being feedback for AI, and actually your tests are feedback for you whilst you're not unemployed and you are actually doing some of the programming yourself. Now, confession. I haven't managed to do this in C++, partially deliberately because I knew what was going to happen and I wanted something that might fit on a slide, so I've done it in Python. I've used a framework rather than coding it up myself. I had to decide how many random trees it would come out with, how often it would recombine to make new trees, how often it would mutate things. And disappointingly, even though you can see the abstract syntax tree in many programming languages, I had to be explicit about which operators and functions it was using. And I did leave it to just find the inputs to the modulus operator, only it was taking days, so I cheated a bit and went, hang it, let's have a mod 3, a mod 5 and a mod 15, which sped it up slightly. I went off piece for a little bit and went, all right, this isn't working, let's just try odd even, and it did manage that itself, but that's not FizzBuzz, so it's not getting the job. So this took several days of tweaking the parameters. It keeps track of the Hall of Fame for you, so you can see how it's improved over time, and it was tending to get stuck around like 5 out of 8, but with a bit of kicking, persuading, and spoon-feeding it really useful functions that might just help. Several days later, as I said, I think if I'd let it do some C++, it was hard enough to make that fit on one slide. Now, I gave it 8 requirements or tests. None of them said things like, don't do anything dumb, like saying, I don't even know where to start with this. There's definitely if it's either buzz or buzz, well, that's a bit pointless. But because it's randomly generating trees, once it had randomly picked either, well, that kind of if-else, it had to slap something in the other bit, and because it never went down the other path, it didn't matter. Now, as I said, this was the Hall of Fame, or as the docs call this variable, if you follow them through, the HOF. I think we actually don't want to look at that code anymore, so I'm going to do that instead. So, yes, enough of the HOF. We can get the computer to generate code for us. We don't want to look at this. What I did there was I spent several days getting the machine to generate some code to do FizzBuzz. I tried really hard not to code up FizzBuzz myself for the tests. I'd spend a long time thinking about the tests. They're vital. Tests are always vital, though. You should have tests in your code. But if we're going to release the machines and they're going to make us unemployed, then the people who are going to make you unemployed need to come out with all the tests themselves. And I bet they can't. They're vital, they're hard to write, and coming out with the necessary and sufficient ones up front. Well, I suppose if you take more of a TDD style approach, we tend not to write all the tests up front. We tend to write some, see what happens, then try some more. And that's an alternative. At the point at which it had generated some of the code, I could say, okay, let's stop, let's have a discussion about this. Let's add some more tests to make sure I can read the code. Or on the other hand, if we're trying to make ourselves unemployed, then no human will ever look at the code ever again, so maybe that doesn't matter. Now, the DEAP framework didn't use the AST. I'm sure we all know that Clang can do stuff with the AST for us. I could give you loads of examples. How are we doing time-wise? Good. So, we could use Clang. Does it matter what language we use? I talked earlier about us not necessarily building hardware or doing machine code. If we're going to make ourselves unemployed, why not just let it come out of some random noughts and ones? As mentioned, Koza invented the genetic programming paradigm, and I've seen some examples that just do random things with noughts and ones. You can imagine what might happen if you were to run that straight on some hardware, though. I'm not sure that's a good idea. Found a variety of discussions about what sort of language would you make yourself unemployed with. Okay, yes, but machine code, modifying machine code in arbitrary ways is pretty inconvenient, one way of putting it. I mentioned John McCarthy coining the phrase AI earlier on. A part of the reason he invented Lisp was so that it could be self-modifying. So, like, the beginnings of Lisp was part of the beginning of the AI revolution. We can do similar things in C++. We can the language refer to itself in a sense. Though he needed garbage collection because, well, you do at that point. Yeah. So a programming language invented specifically so it could be self-modifying as a step towards the machine learning how to program itself. But I said I've not had time, frankly, to try and make the C++ work. And we know with LLVM and Clang setups, we can play around with things. Another advantage of Python is there's not the long compilation times and things. If you're doing something a bit more serious than FizzBuzz, you might have to wait a while for the compiling and linking, so the option to do just-in-time compilation is really useful. This paper points out some ways of doing genetic programming using the LLVM JITted compilation. But like I said, I've not had time, so this isn't really a keynote, it's more a plea for help. If any of you have got time and inclination to play with that, I would absolutely love to see the results. And I'll edit a magazine, so send me what results you get. Let's talk about this. Actually, you don't need to evolve a whole program You can evolve bits of a program. Also, like, what's the optimizer doing? That's the program fiddling with your program for you. Is that AI? Or is that something on the automation or augmentation scale? It's all a bit blurry. What have we seen so far? Well, I've talked about feedback and iteration being recurring themes. And if we try and do everything up front, then it all goes a bit wrong sometimes. We need a human in the loop somewhere. If you look at the phrase human in the loop, that's got a long history in AI, and we'd forgotten about it. And in the last 12 months, I've seen people talk about that more and more. They're tending to use it to mean labelling data for the machines. They can spot cats or dogs or do automatic translation for you. But it used to mean so much more than that. It wasn't just about you being slave labour and labelling things for the machines. It meant you can, no, actually, I don't like that. I'd rather you did it like this. Well, actual interaction. And furthermore, actually, I think that's how we learn too. From some feedback, from some try again. And actually, some human interaction. Talking to each other, helping each other out. So take the opportunity during the breaks to talk to each other, help each other out. Maybe we can be actually intelligent if we do that. Can machines think? I don't know. And I mentioned the Turing test. It's worth rereading Turing's original paper there. It's not a hardcore maths one. And it talks through loads of ideas. So if you've not read the original Turing test paper, go find it and read it. About 5 to 10 pages long. Really interesting. Okay, talk about everything's done by machines. I think I have proved that yes, AI can replace programmers. It can automatically generate code to do exactly what you tell it. Careful what you wish for, though. I mentioned Turing's paper just now. He started talking about digital computers. I think that was the first time I've seen the phrase used. But we've seen AI can code. I mentioned in passing it can design hardware as well. That means the software could design the hardware, which means the machines could build themselves, which means the robots are coming and they're going to steal our jobs and take over the world. Or maybe some kind of augmented Cybermen. And I mentioned the cybernetics book, and we've forgotten that's where the word cyborg comes from. Perhaps we don't need to be afraid, though. I don't know. Does AI need a physical body? I mentioned about the hardware versus the software earlier on. Can you think without a physical existence? Could you upload your brain in cyberspace? Is the machine learning to think? Does it have rights? Do we need the hardware? Certainly I wouldn't be able to do this talk without some hardware. What's real, I don't know, but some sense of physical interactions with things is important. Or is it? I don't know. Lots of questions, lots of sci-fi stuff, always. Should we be afraid? Should we be very afraid? I don't know. A bit. Your life as it has been is over. Are things changing? Why have we stopped talking about machine learning? Why has everyone just started to talk about AI recently? Except a lot of it's in the same sense of that thermostat or the governor earlier on. We talk about our phones being smart. Is your phone smart? It's useful. Okay, I said, are we all going to turn to cyborgs and cybernetics? Old book, like I said. I love seeing things circling around. Maybe some of you recognise the Kubernetes logo in there. No? Okay. Trying to deploy some AI and machine learning things is difficult, so we need a conversation about that. And if If there's anyone here who's really good at testing things and deploying things, talk to people who are doing machine learning by clicking buttons in wizards. Let's have a conversation about how we deploy things, how we test things, how we keep an eye on our systems. In fact, let's do that even if we're not doing AI, because it's nice if your code just works and you've tested it well and you know what it's up to and you can check it's doing the right thing. The cyborg, the cybernetic part of the word means about steering, being a pilot. So I encourage you to become cyborg, steer things a bit, learn how some of this works, watch what's going on, find out stuff, because we're all technically minded, and to me that means you want to look inside, underneath, see what's going on, understand how things work, and open up the conversation. So let's steer this towards a good thing. Music and games and fun and helping people. Back to this one again, but this time, why are you doing it? Why have I got a self-driving car? I want the teleporter instead. Think about the purpose. Say, why are you doing this? Why can I buy a kettle that can connect to the internet? Just because you can doesn't mean it's a good idea. I mentioned Robocop earlier on. Actually, there's a variety of ways in which AI, or at least tech, on some spectrum, can help people. Just looking at, if you start looking at some of the tech behind artificial limbs and things, there's some AI in there. Whether it's actually artificial intelligence or just kind of cool tech that does something useful and helps people is a question. Well, tech can be cool. Perhaps we should call it tech instead of AI. Slightly less controversial. We can borrow some of the ideas from so-called AI to actually make our code better. I think I've taken myself to a point now where AI can replace programmers, but it's just too much effort. It took me days to do FizzBuzz. I could have coded it myself in 5 minutes. There was no point. So let's learn from AI algorithms. Loads of them iterate and do something random. I can think of at least 3 different ways of doing something random at your code to make your code better. Anyone come across mutation testing? Some of you have. Right, so I've got some tests. Are you sure they're good enough? If I randomly change the code, which the genetic programming was doing that, was randomly mutating stuff. If your tests all still pass, if you change a less than to a less than equals and the tests still pass, you've probably missed some test cases, right? So actually, like randomly mutating your code, you can learn from. Well, that's cool. And then you can make your code better rather than making yourself unemployed. So that's a good thing. I said trying to find the tests for FizzBuzz in advance was difficult. I borrowed the set of 8 tests from Kevlin Henney. Those were more like properties. They were statements that were generally true. It didn't have specifics in. It didn't say 1 in gives 1 out, 2 in gives 2 out, 3 in gives fizz out. It hadn't re-implemented the whole FizzBuzz in the test. It stated in terms of general properties. Loads of times if you look through the test code for a code base, you'll see some magic numbers in there. If it needs a date, somebody will inevitably have put their birthday in. If it needs a string, it probably says hello world or something, you know. But then that's missing some possible edge cases. If you change your thinking and put things in terms of properties, property-based testing will then generate some numbers and strings for you and see what happens. And actually some property-based testing frameworks are using things like genetic algorithms to try and zone in on areas where things might go wrong. And then more generally, fuzzers, just shoveling random inputs in. Now some of them, again, are more intelligent. Well, I just said I'd say tech instead of AI. And try and zone in on places where things might end up core dumping by seeing what's happening. So actually, you can make the world a better place. You can make your code base better by trying some random stuff. So perhaps we should embrace this and not be afraid. Just, right, okay. That's about testing our code. But predictive text, I mentioned like smartphones just now. I mean, people keep playing games on Twitter about type the 3 or 4 words and then see what happens next. I think I joined in one the other day that said programming is all about, and mine came out along the lines of, I need to get the data and take it to the pub, which probably tells you far more about me than you need to know. But anyway, predictive text falls under the AI umbrella. Whether it's AI or not, I don't know. It's tech doing something, and we are giving it some feedback to make it better. I've noticed that some IDEs are claiming to use AI for predictive IntelliSense. So rather than just say, you type dot and it gives you 500 possible member variables you could pick from. Shouldn't have 500 member variables. But anyway, it'll narrow it down depending on the type, at least. Whether that's AI or just using the type system to be a bit more helpful is a thing. I had a more general search and thought, okay, I bet if I put AI-generated code into a search engine, it will find me something. And sure it did. There's a thing, now, Python just now, there's the thing, guess you pronounce it Bayou, which apparently uses deep learning to write code for programmers. You'll be pleased to know this is in Java. So what you do is, it helps you design your API. So you say what inputs and what outputs and the name of your function. And if, as you're implementing it, you can't quite remember, say, how to open a file, or in my case, how to code FizzBuzz, you give it some hints and it generates code for you. I think it's doing something like going to Stack Overflow, trying various different bits. I don't understand how it's using the deep learning in here. So I got it to do FizzBuzz. I realise many of you can't actually read that, but that's okay, because you do not want to look closely at what it's done. Basically, I say, takes nothing in, returns me a string, and it's declared a string, and a string buffer, an int, an abstract string builder, and another string, and another int. It's made a string buffer, and then it's made a new string which is put into a new integer, which is turned back into a string, which is, anyway, I don't know. I think that'll end up returning an empty string. The trouble with this is, according to my definition, it's not AI. It's done something random, tick, 50%. There's no way of giving it any feedback or seeing if it's any good. And that was one of many. You could keep scrolling through and it would keep coming up with more and more suggestions. I'm not sure if it's useful. I can see how you could possibly sketch out your API, but possibly at that point there's no point in automating it. And you might as well just go off to Stack Overflow yourself and copy and paste the code out of the answer rather than using the deep learning system. But yeah, so the slides will be somewhere. It's got an online thing you can just try stuff out, and it's hilarious the things it comes out with. I entertain myself for hours. Go play with it. Wow. Feedback is really important. So yes, give feedback to things and set things up so as you can get feedback too. Otherwise, horrible things happen. Okay, so AI can replace us, it can help us, or maybe it's all just tech. Would AI invent its own programming language? Or would it just do things in machine code? Would it create a compiler or interpreter? It's all very well it generated FizzBuzz code in Python, but it needs an interpreter to run. And we came out of that idea. Where would AI be without us? And yeah, would a machine bother with a high-level language if it could build its own hardware and its own robots and take over the world? Do we know what AI is now? Have I helped share my expertise? I think I've just thrown out questions and some random ideas, to be honest. But serious point, though. For a while, people quipped about AI standing for almost implemented. And there's something serious in there. My undergraduate degree is in maths and philosophy, and people quip about philosophy, that as soon as philosophy actually understands something properly, like physics, it then becomes its own discipline with its own name. And in the same way that people regarded thermostats as like strange, spooky machines controlling the environment for them, then now gets regarded as air conditioning or central heating. And once you've got a name for it, it's less scary, becomes a separate discipline that's better understood. So philosophy is still this amorphous place where we ask vague, wandering questions and go off on tangents. And AI is kind of there as well. The things that we haven't turned into a robot vacuum cleaner or a specific thing are still there. As soon as AI successfully solves a problem, it's no longer part of AI. If you look back through history, in maybe the 70s or so, there were lots of things called expert systems, where you enter data into a computer and it diagnoses an illness, or it automatically decides if you're allowed a mortgage or not, and so on. And loads of people got funding to build new expert systems to replace humans and save costs. And it overpromised, under-delivered, and then there was the AI winter, where if anyone mentioned AI, they were not allowed any money at all, and people stopped talking about it. And in the last few years, we've started talking about it again. And there's loads and loads of startups. I lived in London for a while, just moved away this year. And 90% of startups claimed they were using AI because that was bringing in money. And I think we're about to hit a point where we go, hang on a minute, A, it's not AI, and B, it's not doing anything useful, and C, can I have my money back, please? So I think we're going to stop talking about AI soon and start talking about the specific problems we're solving. Apart from, in the background, all the way through the history of this, there's been talk of like chess and Go and computer games and things. There's always games in the background. The games are fun, and that's all right. That's a good thing. We didn't actually try to define AI, failed. Haven't actually defined what a programmer is. And here's maybe a positive note to start drawing it together on. Originally, programmers were people. We know that. If you read stuff written in the 50s, they talked about computers, not programmers. And by computers, they tended to mean female graduates from Oxford or Cambridge sitting down manually doing some hard maths to work out like firing tables for various military setups. And then as they started to build mechanical computers, digital computers that would calculate the firing tables instead, the women went, us computing, us being the computers, have been replaced by the machines. We're going to be unemployed. But no, what actually happened was that those ladies learnt to program the computers. So, some examples of someone taking 30 hours to calculate something. The machine could do it in a few seconds. But the machine needed programming. So they stopped doing the laborious manual calculations, learnt how to program the computers that had made them unemployed, and they got a much more interesting job. So maybe even if the AI can replace some of your day-to-day work, maybe that's cool. Maybe you'll get to play with some more exciting stuff, and it can go meta. And you can write the code that generates the code for you. So don't worry. There's prior art for this, and things never work out the way we expect. Can AI replace programmers? Yes. But, which language will it use? There are loads of AI frameworks, and we saw, maybe you couldn't see the Java code that got generated, but that's a good thing. We need to give feedback. We need to steer. We need to become the Cybermen ourselves. You need humans in the loop. Will AI replace programmers? No. But there's some interesting, exciting opportunities here. Lots to learn. We don't know what it means, really. It means different things to different people and changes meaning over time. It's not as hard as you think. It is just a loop with some randomness and some feedback. But you should do that anyway with what you're doing. Randomly try some scratch refactoring and see what happens. Talk to each other. Did I mention I wrote a book? I mentioned I wrote a book. Will AI replace us? Well, maybe, maybe not. Basically, I don't know. But the FizzBuzz code it generated was horrific. And on that note, I'm going to stop and see if anyone wants to ask questions or just chat to me. Thank you for listening.
Oh, okay, yeah. If you turn it on, it works. So, thank you so much for this great keynote. I have some experience with, I wouldn't call it AI, I have experience with algorithms in this field, like in image recognition. There's
Right.
a lot of things going on, like face recognition.
Yes.
And could you just quickly give an answer to what are the flaws in the system you see and that are not coming from us, or
I don't feel I know enough about this and been doing more background reading, but a perennial problem with things that learn from data, apart from the carbon footprint, which is a different discussion, is I've seen systems that tending to get pictures of white men. So they can point out, they'll spot a face if it's a white man's face. If you've got a non-white, non-man, then that's been labelled as a gorilla, and some shocking things have happened.
Yeah.
But that's about the lack of diversity in tech, and people tend to use people in their team or the students in their cohort as the training data, and so the training data is not wide enough. It's not, there's an inherent bias in the algorithm, though I've seen people claiming that and not managed to trace down to where the maths is biased. It's always been, I like to call it garbage in, garbage out, or bias in, bias out. If you haven't got enough diversity in the stuff you show your child or your AI, then you get bias back out the other end. So I think it's a data problem, though I'm aware not everyone thinks that.
Great keynote, thank you. I was thinking about the code, Python code your algorithm has generated for
Don't
FizzBuzz.
do that, you'll get a headache.
But my idea is that the code for recognizing cats and dogs in the images probably looks, the weights in the neural network looks same ugly as the generated Python code did. Do you think the problem might be that there is no way how to optimize the network in itself because it will generate equally ugly result by training it?
Possibly. I mean, people frequently say the trouble with neural networks is I quipped it was just multiplying and adding up, but it's come out with loads of numbers to multiply, and sometimes it's adding up or sometimes it's exponential functions or whatever. If you write down on a bit of paper the sum it's doing, it will be equally horrific, and you just look at it and go, I have no idea what it's up to. Now, I've done some stuff with trying to turn neural networks into decision trees so you can kind of see what sort of thing it's doing. But they always end up being like a summary of it and don't get the same accuracy of results. So, and that adds to people being afraid of AI because we don't understand what it's doing really. Well, we do. It's a really, really long, complicated sum, but you can't necessarily test out the edges and see what happen. There's an area called adversarial machine learning, which can mean one of two things. But I've seen things where people get another AI to randomly change a pixel in an image, and it goes from recognising a specific animal, saying it's a refrigerator, with a change of 1 pixel. And actually, that's like how we test our code. Just change a random thing and see what happens. But yeah, it's incomprehensible, it's horrible, and it's kind of weird and interesting all at once. Yeah. Don't know if that really answered the question, but that's a big discussion to be had.
Thanks.
Thank you.
Hi.
Hiya.
That was fun. I have a question. Like, so there are many places where would you see heuristics, like optimizers?
Yeah.
I don't know. That basically are like there are a few input numbers, right? That you can tweak a little bit, right? And sort of know align, not align.
Yes.
Things like that, right? So we kind of two parts. Does it make sense to replace those heuristics with learning, like, and how much effort it is versus how much you care?
One, does it make sense? Well, nothing makes sense, and like science, try it, see what happens. I mean, in terms of some machine learning algorithms, I was saying earlier on, you need to choose the number of trees or the number of things you set up to begin with, and you don't know how to do that. So you can get more machine learning to try that out, and then you can get more machine learning to try that out. So you could try some kind of genetic algorithm to try some combination of these switches on, these switches off, and see what happens. But you'd need to state your test, your success criteria.
You have
Otherwise it
benchmarks
won't
for
work.
that, right? If you talk on optimizers, you have
Yeah,
benchmarks.
so you could loose a genetic algorithm on it. That was your first question, and I've now forgotten the second question.
How hard it is.
How hard? Well, I think that'd be quite straightforward. You could write a script that just tried different numbers and saw the output. Should you? That's a different question. Certainly, maybe instead of automating something straight away, do it manually 2 or 3 times to see if anything interesting appears to be going on. Yeah, you certainly, as soon as you're trying to find combinations of switches to do something, genetic algorithms are right up there with the thing to try. Should you? Don't know. Report back. Write me an article.
All right, thanks.
Thank you.
First, thank you very much for your keynote. When we write code, and I take a specific example, when we refactor code, we don't change code randomly. We are changing code based on some beliefs that we have. And while it might be difficult for us to express what these beliefs are you aware of any attempts to express those beliefs in AI and not just change code randomly, but do what we believe that we do when we improve code?
So there's a guy called Chris Simons who works at the University of West of England, so around Bristol, who's been researching some automatically generated code, and he swears blind that the best way of doing this is the human in the loop thing. So it generates some code, and every few wangs around that loop, you go, wait, and some humans sit down and discuss it, and then give the code it's generated a mark out of 10, maybe, and that gives it some feedback. Now, then you don't need to do that explicit recipe or come out with cyclometric complexity or some other metrics for it. You just look at it and go, ugh, or ee. So even if you did sad face, happy face as feedback once in a while, it would start learning what kind of things you liked. But neither of you would be able to be explicit about it. But if you do that halt and the human in the loop giving feedback and going, yeah, yuck, or, oh, that's all right, then you don't need to be explicit. You can just say how you feel about it. That's the thing, human in the loop. Look it up. It's a thing.
All right. Thank you.
Thank you.
Hi, also
Yeah.
thanks a lot for the talk. It's not so much a question, but a note. You mentioned programmers already using tools for their work, like compilers. There's actually, reminded me, there's a thing called profile-guided optimization.
Yes.
Where we do collect data in order to decide whether to unroll a loop or to hint a branch, whether it's likely or unlikely. So there's already kind of this learning aspect. It's maybe not as iterative as it could be, but still it exists.
I think as soon as you start looking at what code your compiler's actually generated, we are using the AI to generate our code for us, really. And I'd forgotten the profile-guided optimization example. Cool.
Yeah, thanks again.
Thank you.
So another thing, I would like to announce something, because my own automation, because this event actually is heavily built on automation, so thanks for it. That's awesome. But we kind of failed, or I failed, my automation failed. I don't know who to blame for. You know, usually you blame the algorithm nowadays, which is like really strange. You know,
Smarter AI.
the AI failed, the algorithm, nobody knows who's, but in this case, I think it's me. The lightning talks will happen tonight at 8:30 here, but they're currently not listed in the schedule, so I will make that happen. But I just, want to make sure that you are aware that the lightning talks are today, that they're here 8:30. Come by, enjoy them, and I will update the schedule. Thank you.